Alright class, so let's continue taking a look at how we can see different forms of implicit differentiation problems. So let's go ahead and take a look at what this problem is asking. It says, consider the curve with this equation, and part A says find all points on the curve with x coordinate 3. So let's think about what that means. If I'm looking for points on a curve, this keyword points, aren't points always given in the form x comma y? Right? So to answer this question, I need to have an x, I need to have a y. If I continue reading, they give me our x value. They say, okay, well, find points when x is equal to 3. So in order to do that, I don't have to do any calculus at all. I just have to do some algebra. So I'm going to plug 3 into every x right here. So I get 3 squared minus 3y equals y squared minus 1. So now you might be asking, how do I find these y's? Well, in order to find these y's, what we're going to need to do is use some algebra. I'm going to move this to this side as well as this to that side. And if I do that, I get 0 is equal to y squared minus 1. 3 squared is 9, but I want to move it that way, so I'm going to do minus 9 plus 3y. And if I combine my like terms and write all these in order, I get y squared plus 3y minus 10. And just like our problems in the past, I'm going to factor this. So if I factor this, I get y plus 5 times y minus 2. And I'll set both of these equal to 0, so y plus 5 equals 0 is y equals negative 5, and y minus 2 equals 0 is equal to y equals 2. So in order to completely answer this question, I'm going to need to write my answers in points. And so for both of these, I plugged in the number 3. So my x value is 3, comma, negative 5. And here, it's going to be 3, comma, 2. Alright, so let's take a look and see how we can solve the rest of this problem. It says, write the equations of lines tangent to the curve at the points found in part A. So let's color code our points. My first point was 3, comma, negative 5. And my other point was 3, comma, positive 2. Let me go back to make sure I have my signs right. Oops. Yes, that's right. Okay, so if I continue, I need a tangent line. So in order to do a tangent line, what does that need? I'll write this in the middle. I need y minus y1 equals dy dx times x minus x1. So our answer needs to be in this format. And we have most of the information. We have our x and y's here. And for my other point, I have an xy here. So the only thing we're missing is this dy dx. So let's find dy dx and then solve this. So our original problem says x squared minus xy is equal to y squared minus 1. So let's find the derivatives. This derivative is 2x. This right here is the product rule, so the first term times the derivative of y is dy dx, plus the second term, y, times the derivative of the first, which is negative 1, which is equal to the derivative of this is 2y, but I have to stick that dy dx in here, and that derivative is 0. So the question is, do I need to simplify all of this and then plug in, or plug in and simplify? Well, the easiest thing to do is to plug in and then simplify. So let's first take our green point. So if I take 3 and negative 5, I get 2 times 3 minus 3 dy dx. And I'm going to move that minus sign here. Y is negative 5 equals 2 times negative 5 dy dx. Let's go ahead and solve these right here. If we solve this, I get 6, and I'm going to change that to a plus 5 minus 3 dy dx is equal to negative 10 dy dx. Right? So let me continue to do this. And we get 11 is equal to, I'm going to move this over here, so negative 10 plus 3 is negative 7 dy dx. And then in order to get dy dx by itself, I divide by negative 7, and dy dx is equal to negative 11 over 7. Alright, so now that I have this, I can create our tangent line equation for this problem. So let me give us some space. What we have here is y minus, I plugged in a negative 5, is equal to negative 11 over 7 times x minus 3. Good. So what we're going to need to do is do the same exact thing. However, we're going to have to use our other problem. So let me split the screen and let's repeat this, but instead let's use our blue point. So that's what we're going to use right here. So in order to do this, I'm going to use this equation. Let me highlight it. And then plug in our 3, 2. So let's do this. We get 2 times 3 minus 3 dy dx. Our y is now 2, so I have 2 times negative 1 is negative 2, is equal to 2 times 2 is 4 dy dx. Sorry, my writing is getting messy here. If I simplify, 2 times 3 is 6, minus 2 is 4. Is that correct? Yes. So I get 4. I'm going to move this over here, which gives me 7 dy dx. And then once again, divide by 7 to get our answer. And our dy dx is equal to 4 over 7. So for this problem, I get y minus 2 is equal to 4 over 7 times x minus 3. Let's just hope my algebra is right, but I believe that should be good. Alright, any questions on this piece? Alright, so let's go ahead and take a look at the next problem, and I'm going to unsplit the screen just so we have more room. It says, find all points x, y on the curve where the line tangent to the curve has a slope 4, 7. So I want the tangent line to have a slope of 4, 7, which means my dy dx needs to equal 4 over 7. So if we go back to the previous page, let's use this one right here. We never really simplified this, so let's actually simplify it. Let me erase that, and then let me copy this whole thing. Right, so let's see, copy, and let me move over. Let's paste it right here. Let me move that down. Okay, so I need to simplify this portion. Oh, and that's a 4, so let me make sure I fix that. I want my dy dx to equal 4 over 7. So right now I don't have a simplified dy dx. We're going to need to do some algebra to do that. So let's collect our like terms. I'm going to move this over to this side and then see what we get. So I get 2x minus y is equal to 2y dy dx plus x dy dx, right? And so what I'm going to do is I'm going to factor out my dy dx, and I get 2y plus x, and this side stays the same. So now to get my dy dx by itself, to divide by 2y plus x, divide by 2y plus x, this cancels out, and so our dy dx is equal to 2x minus y divided by 2y plus x. Yes? Okay, so now let's go ahead and set this equal to 4 over 7. So now you may wonder, okay, how do I find this, Miss Hollow? So we're going to cross multiply just like we did in algebra. And what you're going to notice is the rest of this is all algebra. So I cross multiply this, and I set them equal to each other. So I have 7 times 2x minus y is equal to 4 times 2y plus x. And then let's go ahead and solve these pieces out. We get 14x minus 7y equals 8y plus 4x. Okay, and so if I combine my like terms, I'm going to get 10x is equal to 15y. And let's just take a look and let's solve for x. To solve for x, I'm going to get x is equal to 3 over 2y. Okay, well, this is nice, but I don't have an actual point, so what should I do? Anytime I have an x and a y, I'm always going to plug into our original equation. So let me split this so that we have some room. Alright. Can we see our problem here? Okay. I don't think you guys can see it. Let's just write it right here. We said x is equal to 3 over 2y, right? So let me unsplit the screen, sorry. And then let's actually plug this into our original equation. Our original equation says x squared minus xy equals y squared minus 1. So everywhere I see an x, I'm going to plug this in. So there's an x here, so I get 3 over 2y squared minus 3 over 2y times y equals y squared minus 1. If we do our math, I square the 3/2 and I square the y, which gives me 9 over 4y squared minus 3 over 2y squared equals y squared minus 1. So fractions are our friends, and let's go ahead and take a look at this. We get, let's see, if I multiply this by 2 and this by 2, that gives me like terms. That gives me 3 times 2 is 6, so 9 minus 6 is 3 over 4y squared equals y squared minus 1. So let's continue solving this. Let's move things over. I'm going to move this here, but move this here. That gives me 1 is equal to y squared minus 3 over 4y squared. And if I continue, I get y is equal to 1 over 4y squared. So I'm going to multiply both sides by 4 just to get rid of that fraction. 4 is equal to y squared, so y has to equal plus or minus 2. Which means I have 2 points that this works for. Now the question is, how do I find my x? Well, what I do is I need to go back to this equation right here and plug in positive 2 and negative 2. So we said, let me extend this. We said that x is equal to 3/2 y. So the first thing I'll do is plug in a positive 2. That gives me 3. So I would get 3 comma positive 2. That's 1 point. Next point, I plug in a negative 2. So these cross out, but now I get a negative 3. So my second point has to be negative 3 comma 2. These are the 2 points that we get the derivative of 4 over 7. And just to take a look, earlier we found a derivative of 4 over 7 when I had the point 3 comma 2. Perfect. So what I would like you to do is in your, I believe it's the orange packet, let me find mine, I would like you to complete these 2 problems as your exit slip. Number, it's page 9 on the orange sheet, and I want you to do number, let's do number 23, and I'd also like you to do number 25. Okay? And for homework, I would like you to watch Implicit, Differentiation, I believe we are now part 5. So go ahead and check Edmodo and watch that for homework, and I'll see you on Thursday. Don't miss me too much. Goodbye.